Hey everyone, it's algebra time, and today we're going to really begin our journey into algebra with section 1.1, solving simple equations. Now, I'm fairly certain most of you have seen some things about algebra before, but just in case you haven't, we're going to hopefully start from something really basic. So, we'll see what we have here. Now, first thing I need to tell you as we do all of this is that if you don't have a calculator in front of you, you're crazy. You should have a calculator in front of you for this class at all times. So here in exploration 1, measuring angles, it says to work with a partner. I'm going to work with you here. Actually, I'm going to do all the work, and you just have to pay attention. So it says to use a protractor to measure the angles of the quadrilateral. The notation, and it says over here, the M with a little angle and then an A denotes the measure of angle A. And we're going to do this all in degrees. And we're supposed to take this first one here. We're going to measure all the degrees. Now, it's going to be kind of hard to do this, so over here in this website, I've kind of drawn out something similar to what you're going to see. And it nicely just kind of shows you all of the angles. So we're just going to use these angles for our quadrilateral. Now, if we were in class, I probably would give you a protractor, and you'd probably have to go ahead and measure these out. But things being what they are, we're just going to use these measures for our angles. Okay, so let's put all the angles into our handy-dandy chart here. Quadrilateral A. Well, angle A is 90 degrees. You can see that over here with the little number 90. Angle B is 93 degrees. Again, you can see that down over here. Angle B has a 93 degrees on it. Angle C is 73 degrees. And angle D is 104 degrees. Now, what would happen if you added all of those together? Right over here, it says a measure of angle A plus a measure of angle B plus a measure of angle C plus a measure of angle D. And nicely, this program that we're working with right here, this is going to add everything together for me. And it says that if I add all of those angles together, I get 360. Now, we could probably spend more time doing the exact same thing to quadrilateral B and quadrilateral C, but I think you're going to find that you're going to get the exact same thing. So working with your partner, me, you're supposed to write a conjecture. Well, what the heck is even a conjecture? Well, that means take a guess about what would happen for any quadrilateral, any four-sided figure, if I added all the angles together. Well, you would find out that the angles of a quadrilateral have to add up to 360. Now, that's actually a rule that you can prove, which is going to have a different name later. But we have, if we did B and C, then we would have a lot of evidence to show that this is actually a true conjecture. This is a true thing. So it's a rule. Now we could do more here. If this conjecture was true, that means if I added all of these together for quadrilateral A, I should get 360 degrees. So if I added 85 plus 100 plus 80 plus x, whatever x is, I don't even know what x is. Well, if I added all those numbers together, I should get 360. So that's nice. These four angles added together is 360. Well, I can add some of these together. For example, I know 100 plus 85 is 185. So that tells me 185 plus 80 plus x is equal to 360. Let's zoom in a little bit here. And if I did 185 plus 80, that would be 265 plus x is 360. And then here, maybe you're kind of stuck. I don't know. 265 plus some number, I don't know what that number is, that's got to be equal to 360. Now, if I was supposed to do this the algebra way, I'd subtract 265 from the left side and the right side of the equal sign, which I'm sure, well, maybe not sure, but you may or may not have heard about that kind of stuff before. that would get me that x is equal to 95. But really, at this point, starting from right about here, you probably don't need to do algebra to solve that if you're pretty handy with your numbers. I can trust you a little bit with that. But anyways, at this point, we should get that x is equal to 95 degrees. So that actually helps us. That's how algebra is going to help us solve things. I need to tell you that algebra is about as much about the method as it is about the number that you get at the very end. So you might hear me say that over and over again as we go through this algebra course. It's not just about x equals 95. It's how did we get there? Because as soon as we get to something much more complicated, the easy methods aren't going to work anymore. So we're trying to teach you the methods that will help you solve things even when they are more difficult. So how can you use simple equations to solve real-life problems? This is kind of a loaded question. They always ask me to tell you how to solve real-life problems. And to tell you the truth, this is just kind of the basics about how to solve real-life problems. You're probably going to tell me I'm never going to have to measure an angle in my life. I'm going to say, yeah, you may not have to. But the kind of thinking that's required to solve it, that's really what I'm trying to teach you here. So let's, move away from here and let's just talk about this vocabulary. You're going to want to write these down in your student journal or your student notebook. So we've got a conjecture, and a conjecture is just a guess about how things are going to behave. The rule is how things actually behave. So a conjecture is a guess about things. The rule is the way that things actually happen. A theorem is a conjecture that's been proven somehow. Mathematically speaking, as someone who studied math in college, I can tell you that, proving theorems is a major preoccupation of the mathematician. So we just like to prove theorems over and over again, or show how theorems get proved. How does a guess get proved? That's really the heart of mathematics here. Okay, what is an equation? Equation is a number sentence. It shows two things that are equal. So maybe you were going to say something easy like 12 equals 12. Or maybe we'll say something a little more complex like 2 times the number x is equal to 19. A linear equation in one variable. Now this is what we're going to be doing for most of this semester. It's an equation that has exactly one variable with no exponents. Now it is the simplest kind of equation that we can solve, and that's why we're doing it right now in Algebra 1. Once we figure out how to solve linear equations, then other equations become easier to solve. But until we can master linear equations, we can't really do much more with mathematics. Now I want you to note that I'm saying mathematics and not arithmetic, because there's a difference between the two. Arithmetic is just adding numbers together, maybe subtracting, maybe multiplying. That's not what we're in the business of doing here. We're in the business of doing mathematics. Solution is a set of numbers that when solved or substituted for a variable will make an equation true. We'll talk about the solutions of things. It's also a good idea if you kind of separate and think of solution in math as different than the solution, the way that you might use that in regular language. So solution in math is a set of things. Inverse operation. You'll hear me say inverse operation over and over again this semester. And inverse operation, there are really only two that are important to us right at the beginning of algebra. They are addition and subtraction, because they have the ability to reverse each other. So if I add something, the opposite of adding something is subtracting something. The opposite of multiplying something is dividing by something. And then equivalent equations is two equations that have the same set of solutions. So when we do mathematics, what we are doing is creating a bunch of equivalent equations. Try saying that fast. Equivalent equations that become simpler and simpler. which makes this next section with the core concepts, this makes this absolutely ridiculous, because if you see that x equals 9, I could add 2 to both sides, and I would get x plus 2 equals 9 plus 2, which of course would again make an equivalent equation, x plus 2 equals 11. But that's just making things more difficult. X equals 9 is the simpler of those two equations. Over here, we have x minus 2 equals 18. Well, the inverse of subtract 2 is add 2. So what I've shown here in red is I'm adding 2 on the left side of the equal sign, and I'm adding 2 on the right side of the equal sign. And that's going to make these two equations equivalent to each other. They are the same equation. Or no, they have the same solution set. And of course, once we do some arithmetic here, we'll get that a plus nothing, because minus 2 plus 2 is nothing. So just a is equal to 20, which would be our solution. Okay. So we're going to be doing a lot of inverse operation. Here's subtraction. It kind of works the same way. I'm going to go over to the right side because that's really the more interesting of the two. If I have z plus 12 equals 100, I could say z plus 12 plus another 12 is equal to 100, is equal to 100 plus 12, but I'm supposed to use subtraction. So maybe I should say z plus 12 minus 12 equals 100 minus 12. Now there's something similar for multiplication, and I got to tell you, this is where, some students, this is where they start to flounder a bit. So we've got a is equal to negative 9. Well, if we multiply by negative 3, then we got a multiplied by negative 3 equals negative 9 multiplied by negative 3. Again, this is making the equations, the equivalent equations, I'm going from an easy equation to a more complex equation. So that's not what we want to do in mathematics. We want to start with a difficult equation, like 1/2 x equals 10, and we want to go to an easier equation, easier equivalent equation. So instead of 1/2 times x, we're going to multiply both sides by 2. So 1/2 x times 2 is equal to 10 times 2. And that would simplify to x equals 20. Which I have a feeling some of you probably already figured out without doing, the mathematics. And that's great. Don't ever lose that, because that's going to really help you out. I don't want to be one of those people who tell you to, lose your mathematics or your arithmetic for the sake of doing some algebra here. It's not worth it. So this is a very typical thing that we're going to do in this class for the division property of equality. Now here's the important note. In this class, instead of using the division sign, we're going to multiply by the reciprocal. Okay? So when you see 1/2 times 2a, I'm going to often say divide by 2. And I'm going to multiply by 1/2. They mean exactly the same thing in mathematics. Multiplying by the reciprocal is the same thing as dividing. So 1/2 times 2a, that's the same thing as 2a divided by 1/2. 12 divided by 1/2 over here. So we'll get more used to that as we do things. But I really want you to get used to that idea of using the fraction instead of using the division. Okay? So that is, I believe, all we needed to talk about with this part of the video. The next video we're going to look at, we're going to use these basic steps in order to solve these easier equations. Okay? So we'll see you back for the next one.